Alright, so today we're going to be looking at lesson 5.3, solving systems of linear equations by elimination. So we already know, like I said, we know how to solve systems of equations by graphing. So taking two equations, graphing them on the same coordinate plane, and then visually looking for where the point of intersection is, where those two lines cross. That is the solution, and you can find it with graphing. We also know how to find it by using the substitution method. That means take one of the equations, solve it for a variable, either y or x, and then replace whatever it's equal to into the expression, and then solve for then x, and then solve for y, or vice versa. Today we're going to be learning the last method in solving systems of equations, and it's called elimination. So elimination literally means eliminate the variable, so like make it go away. And there are three steps in order to solve with elimination. Step one would be to add or subtract the equation so that one of the variables eliminates or cancels out. Step two, solve for the remaining variable. And then step three, use substitution actually to figure out the answer to the other variable that you didn't already solve for. So elimination is actually an easy process if things are set up the way that they're going to be set up today. So looking at number one, I have two equations, 3x plus 2y equals 7, and negative 3x plus 4y equals 5. Previously, if I said solve this by graphing, you would want to put both of these in slope-intercept form, graph the lines. Not going to be very effective for this problem. Also, if I said solve the system by substitution, you'd have to pick a variable to solve for that variable in order to do the substitution step. I also wouldn't really want to do that one because if you're looking at the four options of x's and y's, none of them seem to be really simple to solve for. So then there's a third method called elimination. And what elimination does is it takes two equations and you can actually add all of the things together or subtract them together to cancel out the variables. So in this problem, I see 3x plus 2y equals 7 and negative 3x plus 4y equals 5. Elimination says you can take two equations and you can either add them or subtract them to cancel out variables. So what I'm going to do is actually add these two equations together because if I do add, one of the variables will eliminate. That means if I take 3x and I add negative 3x to that, these two variables will cancel out because 3 plus negative 3 equals 0. So that variable x will eliminate. Then I can add 2y plus 4y, that's 6y, equals 7 plus 5 is 12. So recap, what I just did was I took the equations and I added the same terms to each other that I can. Like I can add 3x and negative 3x together because they're like terms. I can add 2y plus 4y and get 6y because they're like terms. I keep the equal sign there and I can add the numbers on the right hand side, 7 plus 5 and get 12. Now I'm left with an easy equation I can quickly solve for by dividing both sides by 6. And I already have what y is equal to. Y is equal to 2. So what I did there was I eliminated the x variable. I was able to solve for y, and now I'm going to use that number and replace it in for one of the equations to solve for x. So looking at the original equations, I feel like the first equation is a little bit easier since there's no negative. 3x plus 2y equals 7. And I already solved that y is equal to 2, so I can replace in a 2 for y. And then I'm just going to solve for x at this point. So I would multiply 2 times 2 and get 4. I would subtract 4 from both sides. 7 minus 4 is 3, so I get 3x is equal to 3. And then I would divide both sides by 3, and I get x is equal to 1. So that step was just like the substitution step in the end. When we have one of the numbers, you replace it in and solve it for the other. Then altogether, my final answer would be 1, 2 in ordered pair form. That's the solution to the system. That is the point where these two lines intersect. So make sure you're writing this down just like I write it down up here so that you have your notes complete. Okay, looking at example 2. Example 2 gives us a different situation. We have x plus 3y equals 17 and negative x plus 2y equals 8. When you're solving equations by elimination, what you will do is take the two equations and either add them together or subtract them depending on what you want to eliminate. If I look at these two equations, you're looking at the x's and the y's. What variable will go away? What variable will cancel out if I take these two things and add them together? Yes. If I take these two equations and I add them together, the x's are going to cancel out since 1x plus negative 1x is 0. Then I can add the rest of them straight down. I'm going to have 3y plus 2y, that's 5y. 17 plus 8 is 25, so I get 7y equals 25. Once I have that, I can quickly solve for y by dividing both by 5, and I get y is equal to 5. After you have one of the solutions, then what you do is pick the equation that you would want to work with. I like the first one, x plus 3y equals 17. I now discovered that y is equal to 5, so I'm going to replace a 5 here for y. And then I will solve for x. 3 times 5 is 15, so we have x plus 15 equals 17. I subtract both sides by 15, and I get x is equal to 2. That means altogether my final answer in ordered pair form will be 2, 5. And don't forget, you can always take these numbers and replace them in for x and y to verify that your answer is correct. Now, all of these problems that we're doing right now are specifically set up so elimination can happen. If I look at number 3 is going to be a little bit different because for all of the problems we did so far, number 1 and 2, what I did was I added the equation straight down to cancel out a variable. If I add 7x plus 8x, 2y plus 2y, do any of the variables cancel out? No. So not all the time will you have to add them. Sometimes you can also subtract. If I take this equation, or this system of equations, and I actually subtract the first one minus the second one, then I will also be able to eliminate a variable because the two y's there, 2y on the top and 2y on the bottom, will cancel out with subtraction. So the elimination process allows you to take equations and either add them or subtract them to cancel out variables. It's very important that when you do subtraction, you always start with the top number and subtract the bottom number. So 7x minus 8x is negative 1x. 2y minus 2y cancels out. And 24 minus 30 is negative 6. So right now I have negative 1x is equal to negative 6. Yeah. To get rid of that negative 1 in front of x, since there is a negative 1 here, you would have to divide both sides by negative 1. And you're going to get x is equal to 6. Once you have one of the answers, then you have to pick whichever equation you like better and replace in 6 for x. And then you can solve for y. I'll use the first one again. 7x plus 2y equals 24. I know that x is equal to 6. I'm going to put a 6 here for x. Okay, and then we would solve. 7 times 6 is 42. Then you would subtract 42 from both sides and divide by 2. I'll give you a minute to solve it. We would subtract both sides by 42. And we get 2y is equal to negative 18. Divide both sides by 2. And we're going to get that y is equal to, oops, not negative 8. Y is equal to negative 9. Altogether then, that means that the final answer is 6, negative 9. That is the point where these two lines cross. You can always take your answers and replace them in for x and y to verify that you did not make a mistake. And you can also know that you for sure have a correct answer before moving on. So what we're going to do now is practice this process. I feel like this process is a little bit quicker and easier than substitution. There's not as many steps. And the steps that you have in elimination sometimes are very similar to substitution in the end. So the only new thing that you have to do is when you're looking to solve systems by elimination, you're either going to add the equations or you're going to subtract the equations depending on how the equations are set up. Looking at number 4, 5x plus 6y equals 50 and x minus 6y equals negative 26. You need to decide what to do here with this problem. That means, are you going to add the two equations together or are you going to subtract the two equations? And that is your decision that you have to make in the end. The way you determine that is by looking at the variables. So like 5x and 1x, if I add them or subtract them, they're not going to cancel out. So for this one, I can see the y's will cancel out because I see opposite number of y's. I see a positive 6y and a negative 6y. Because one's positive and one's negative, the only way to cancel these two out would be add them together. So what you would do for this example is add the first equation plus the second equation to get your answer. Okay, so what I want you guys to do is try 4, 5, and 6 on your own. See how you do. In like 6 minutes or so, we'll go over the answers, and we'll see where that brings us to the end of class today. So we're working on 4, 5, and 6. All right, I hope everyone is doing okay. I'm going to just show you number 4 just in case you are stuck so you can see the process again. In order to solve number 4 by elimination, you would take the two equations and add them together. 5x plus 1 more x is 6x. 6y plus negative 6y cancels out. And 50 plus negative 26 is 24. Then once you have this little equation, you can solve for x by dividing by 6, and you're going to get x is equal to 4. Once you have one of the answers for x or y, then you can replace it in for one of the equations to solve for the other variable. I'm going to use the first one, 5x plus 6y equals 50. I now know x is equal to 4, so I can put a 4 here in for x and then solve for y. 5 times 4 is 20, so I have 20 plus 6y equals 50. I would subtract 20 from both sides and get 6y equals 30. Then I would divide both sides by 6, and I get y is equal to 5. Altogether, then, my answer where these two lines cross is at 4, 5. So for each problem, you need to decide if you're going to add the two equations together or subtract them. I'll still give you some more time to finish up 5 and 6, and then I'll go over the answer shortly. All right, so one of the things you're going to have to start getting used to is identifying what will cancel out when you go to use elimination. So for number 5, when I'm looking at the two variables, x and y, you're looking for these two variables to either be the same exact number, for example, like 3x and 3x, or 6y and 6y, or opposite answers, like positive 2x and negative 2x. If they're the same exact number, the only way you can eliminate them is by subtracting, since like 2 minus 2 is 0. If they are opposite numbers, like 3 and negative 3, the only way to cancel those out would be combine them together through addition, since 3 plus negative 3 equals 0. So you have to start getting used to figuring out, first of all, what variables will cancel out, and also what will you have to do to cancel them out. So looking at the two options here, I can see that the x's are going to cancel out because I notice that they're the same exact number but opposite. So what I will do, since those are opposite numbers, is add. Whenever they're opposites, you will add, since 4x plus negative 4x is equal to 0 x's. Then I will take a negative 9y and add negative 3y to that, and altogether I'll get negative 12y. Okay, and then I'm going to get negative 21 plus 9. And you have to just be careful when you do this because you want to make sure your negatives are in the right spot, and you need to understand like what numbers you're adding and subtracting. So negative 21 plus 9 is negative 12. So we get negative 12y equals negative 12. We will divide both sides by negative 12 and get y is equal to 1. Once you have one of the equations, you can quickly solve for the other one by choosing one of the two options at the very top. I'm going to use 4x minus 9y equals negative 21. Both of the equations seem to be equal in difficulty since a lot of them have negatives. I'm now going to replace in a 1 for y since I just found y to be equal to 1. And then I'll solve for x. Negative 9 times 1 is just negative 9, so it's going to be 4x minus 9 equals negative 21. Adding 9 to both sides, I got 4x equals negative 12. And dividing both sides by 4, I get x is equal to negative 3. Altogether, then, my answer would be negative 3, 1 in ordered pair form. I could verify that by replacing in those numbers for x and y and then moving on to the next one. The next one is different since looking at the x's and y's, you need to cancel them out. And looking at the 5x plus 2y equals negative 28 and 5x minus 3y equals negative 8, I know that since these are the exact same thing, the only way you can cancel it out is by taking the equations and subtracting them. So what we will do is take the top number and subtract the bottom number. 5x minus 5x cancels out, so those go away. You just have to be careful when you're doing the next part. You have to do 2y minus, that's a negative 3y. So this can get a little bit tricky with subtraction because if you ever subtract a negative, it ends up actually being addition because subtracting a negative is the same thing as addition. So when we do 2y minus negative 3y, it actually turns into 5y. And then the next thing we'll do is negative 28 minus negative 8, a double negative again. Negative 28 minus negative 8 is really negative 28 plus 8, which is negative 20. So we get 5y equals negative 20. We'll divide both sides by 5. And we get here y is equal to negative 4. Now that I have one of the answers, I choose one of the equations and replace that number in. So I have 5x plus 2y equals negative 28. I now know that y is equal to negative 4. Okay, so I have 5x. 2 times negative 4 is negative 8, so I have 5x minus 8 equals negative 28. I'll add 8 to both sides. I get 5x equals negative 28 plus 8 is negative 20. And divide both sides by 5, I get x equals negative 4. Altogether, I actually have the same answer for both x and y. This final answer here for number 6 would be negative 4, negative 4. So with elimination, your first step is to look at the variables and see, are they the same exact number, like 2x and 2x, or are they opposites, like 2x and negative 2x? If they are the same, you have to take these two equations and subtract them. If they are opposites, you take the two equations and you add them. Once you have that answer, then you will be able to get one of the numbers in for x or y. You take that, replace it in, and you can solve for the other one. So elimination is actually nice and easy because all of these questions were specifically set up so this would happen. But what we're going to see tomorrow, here's just like an introduction to tomorrow's lesson. Tomorrow we're going to see elimination questions that are not set up like that. Like if we just look real quickly at this number 1 here, at 1x plus 1y equals 2 and 2x plus 7y equals 9. If you're looking at these equations, if I were to add the x's straight down, 1x plus 2x is 3x. If I add the y's, 1y plus 7y is 8y. Neither one of the variables right now would actually cancel out. So what we will have to do tomorrow is add another step to the process, which means we would have to multiply before we could actually solve. But that's tomorrow's lesson.